free fall acceleration. Free fall acceleration. Galileo was a great scientist who was sitting with his students, and he asked them a question. He asked them, what if we have two objects, similar, identical object, but one of them with large mass and the other with a small mass, and what happens if they left to fall freely from the same height? Let's imagine we have a bottle of water, and this bottle of water filled till its half, and another one filled completely, and the two bottles are identicals, and you can try this at your home. So the drawing is not in scale, so let's assume that the two bottles are identical, and they left to fall from the same height. Which one do you think will reach the ground first? Galileo asked his students. Some of them, they said the heavier one, and the other said the lighter one, and he said, no, we are going to depend on the practical, so we are going to do this and we are going to check the result. And they found that they reached the ground at the same instant of time. So they reached the ground at the same instant of time, so we have a constant acceleration, and whatever the mass of the object, and if the object is left in the field of the earth, the gravitational field strength will be the same, and we will find that the gravitational field strength G is the force acting per unit mass, and its unit is Newton per kilogram, and the free fall acceleration, which is the same like the gravitational field strength, is also meter per second squared. But what is the value of G? G is 9.81. If the problems with three significant figures, you can use 9.81. If the values in the problem is with two significant figures, you can write 9.8. So if you wrote 10, you will lose 1 mark. So in AS, you have to write 9.8 for the acceleration. Okay, guys. So if we have two objects left to fall, or whatever, if we have an object left to fall freely, the object will accelerate uniformly until it hits the ground with the maximum velocity. So if the examiner asked us what is meant by the free fall acceleration is equal to 9.81 meter per second square, we can say that if we have an object, if an object is left to fall freely, its velocity will increase by constant rate, 9.81 meter per second every second. Okay, guys, so 9.81 meter per second square, it means that the object will accelerate uniformly. Since we have a constant acceleration, a kind of acceleration called the free fall acceleration, and it's a constant acceleration, we can use the same equations of motions. Do you remember? We have the first equation, V is equal to U plus gt. Now I'm going to replace A by G, and G is the free fall acceleration, or S is equal to ut plus half gt squared, or S equal Vt minus half gt squared, or V squared minus U squared is equal to 2gs. So here is the equations for the free fall acceleration. If the examiner said we have an object that left freely, so of course G will be in positive, and it will consider as an acceleration in the direction of the free fall acceleration, always towards the center of the planet or whatever. It's not a universal constant. G is 9.81 meter per second squared till 100 meters from the Earth surface. So even if as we go away from the Earth, the free fall acceleration or the magnitude of the free fall acceleration decreases. So till 100 meters from the Earth surface, we are going to consider it as a constant with 9.81 meter per second square. Some notes on solving problems. Notes in solving problems related to the free fall acceleration. If the object is left to fall freely, so the initial velocity is 0 and final velocity is maximum, and g is equal to 9.81 meter per second squared. If the object is projected vertically upwards, so the final velocity is 0 and initial velocity is maximum, and g is equal to negative 9.81 meter per second squared, since the object is moving upwards. And inshallah, while if we found time, we are going to solve problems related to the free fall acceleration. And until I meet you again, I wish you all